Alright, we're going to continue on from the first video. What we're doing is we're trying to match these equations up with the graphs below. We're doing that first by finding the x value of the vertex and seeing if that gives us enough information. So I'm going to skip E for now and let's go to F. So we're using opposite of B over 2A. The B value is 0. So 0 divided by -2 is 0. See if we can find a vertex at 0, so this one is not at 0. And the x value of the vertex for this one is 0. Sorry, we had the line there already, didn't we? So the x value is 0 and the vertex is on that. Also notice that it's opening down, and since we have a negative x squared, that should be reflected down. So this, it looks more and more like F. And the last one, opposite of B over 2A gives you -7 over 2. So the vertex should be at -3.5, but we noticed this one, -3.5, it's not quite where it hits, is it? -3.5 should be right in here. So there's a mistake, I guess, in this one, huh? But let's look if we can match other things. So we've only been looking at the x value of the vertex, and that has tended to be enough. This is your value when x is 0. So here's where x is 0. Does it seem like this green line would hit at 15 if I continued up? It seems reasonable to me. Notice that the a value is positive, so it's +1, so the u is going up. And lastly, one thing we can think about is that a +1a is our standard over and up. So over 1, up 1, over 2, up 4, over 3, up 9. And you can see we get that relationship here. So it would be reasonable to assume that this is supposed to be E, and there's just a misprint in your B value there. So, all right. Very good. If you need to pause and look back at this, I'll zoom out for you. And if you want to go ahead and pause, I'll move on to the next one. All right, graphing the inequality. This inequality is in what we call vertex form. So our vertex form is a times x minus h squared minus 5. The a value is 2. The h value, now it's supposed to be minus h, but that's a +2, so our h value is actually -2, and our k value is -5. So with the h and k, that tells us the vertex. So we know that the vertex is at -2 is your h value, and -5 is your k value. That gives you the starting point. From there, we're going to move up and over according to A. So here's our over. The up is always just ax squared. That's what the up is. So if x is 1, if the over is 1, it's going to be 2 times 1 squared, which is 2. If the over is 2, it's 2, your a value, times 2 squared. 2 squared is 4, 2 times 4 is 8. If it's 3, which we normally don't always get to, it's 2 times 3 squared. 3 squared is 9, times 2 is 18. The reason we say over is because axis of symmetry means this is left and right. Over is both left and right. So let's go ahead and plot these points. We said our vertex was at -2, -5. I go over 1, up 2, because my A value is 2, axis of symmetry. I go over 2, I'm going to go on this side now, over 2, up not 4 but 8, so there's 3, 4, 5, 6, 7, 8. Axis of symmetry. And I won't be able to get 18, so go ahead and connect this the best you can. You have that wonderful Desmos graphing calculator. You could always plug this in there and check your answer. I'll zoom out. If you need to pause and copy that down, go ahead. I'm going to move on. Alright, number 6 says match the transformations to the graph. Remember, transformations are based on the parent function y equals x squared, which goes to 0, 0. And looks something like this, I hope. Sorry, not perfect. Maybe we should be perfect, huh? A little closer to perfect. Oh, terrible axes. So, should go something like this. Still not quite right. Better. So, and this is the 1, 1, 2, 4, 3, 9 pattern for our parent function. Alright, let's zoom out and see what transformations we have. Transformation just means how is that changed. So when I look at this first one, I notice there's a rock, so there's a reflection over the x-axis, and it does not appear to be 1, 1, 2, 4, so there seems to be some sort of vertical stretch. But there, since we're at 0, 0, there is no left or right shrink. So let's see which one of these. Rocks, vertical stretch by a factor of 2. Seems like this goes with D. Let's change colors. We look over here, so here's where our vertex is. Supposed to be. The blue is where it's supposed to be. And we'll change to a different color, black probably. This is where it is after the transformation, so sure looks like it was shifted. Zoom in. Shifted 1 to the left and 2 down. And after that, we notice that over 1, up 1 should be right there, but it's not. It looks like it went over 2, not up 4, but over 2, up 2. It was supposed to go up to 4, so it has been shrunk. This point was supposed to be there, but it's moved down. So we have a left shift. We have a downshift or a shift down. We have a shrink. And it's shrunk by a factor of 2. So vertical shrink. Baffle is by a factor of 2. Let's see if we can find this. Looks like it's right here, huh? So this is transformations B. Alright, let's look at this one. How about some green? Zoom in. So our vertex is supposed to be here, but it's all the way down here. So that's 1 to the right and 2 down. So shift right. It's supposed to be the word shift, huh? And shift down. We would normally go over 1, up 1. And there should be a point there, but there's not. It's gone up. So it's stretched. This point has been stretched up. Now it looks like it's been stretched up 1, but remember we're counting from down here. So instead of being 1, it's stretched to 2. So there's a vertical stretch. We call that a factor because it's actually multiplying by a factor of 2. Let's see if we can find that transformation. Shift right, shift down, vertical stretch by a factor of 2. And close, huh? So these, it looks like it should be A. We're just missing that vertical stretch. Maybe the computer changed the graph a little bit. Should be A has the transformations, has 2 of the 3 transformations. So we'll count that for now. And let's look at the third one. So zoom in. Our vertex should be at 0, 0 for the parent function. It is shifted left 1, so we have a left shift. From the vertex, it looks like we go over 1, up 1, over 2, up 2, 4 seems right. So there is no vertical stretch or vertical shrink. It's not shifted up or down. It looks like we only had one of them that had a mistake. This looks like C. So sorry about A. And let me zoom out, and you can pause if you want, and then move on to the next one. All right, down to 7. Write a quadratic function that has a vertex and goes through the point. Vertex at 2, negative 3, and goes through the point 4, 1. So here we're going to use our vertex form, which is y equals a times x minus h squared plus k. I don't know that there's any real magic to this. You just kind of need to memorize. Remember that our vertex is at hk, and the point is going to give us an x and a y. So we'll try to use some colors here. So if h is positive 2, then a 2 goes right in there. If k is negative 3, then we're going to put a negative 3 in there. If x is 4, for our x value, we're going to put 4. If y is negative 1, then for our y value, over here, we're going to put negative 1. Notice that we don't have anything for a, so we're going to have to solve for a, and then rewrite the equation. So let's get to work. We're going to have negative 1 equals a times 4 minus 2 squared minus 3. Everyone should be able to do this. This is order of operations. So the first thing we do is do the inside the parentheses. Then we're going to do the exponent. So we're going to square the 2. And actually, I'm going to add the 3 at the same time since we're solving. So let's move the 3 and square the 2. So negative 1 plus 3 is going to be 2 equals 4a. And a is a half. We need to divide both sides by 4. 2 over 4 reduces to 1/2. So we need to write the equation, which we don't seem to have room for, do we? I'm going to put it in blue over here. Whoop. So the equation, y is a letter, a is the number, 1/2, x is a letter, and everything else are your numbers. Minus 2 squared minus 3. There is the equation of that line. If you need to finish copying that down, go ahead. We're about out of time. Seemed like all we could get through was 2 videos yesterday. So if you want to go ahead and see what you can do on these for the rest of these, we'll pick it up on Friday. And a lot of you need to finish your worksheet from yesterday as well. Okay.